VLSos here. This is a video lesson on basic probability. I've started with an example. What is the probability of flipping heads on a coin? We may know the answer to this question. We want to slow down and talk about how we can use notation to ask this question and answer it. Notation for asking a question for probability could be of this form. We use a P to stand for probability, and inside parentheses, we put the event that we're looking for, or that we would consider a successful outcome of the probability that we're analyzing. In this case, with the probability of flipping heads, we're looking for our event to be heads. The question is the probability of that heads as the outcome. Now we calculate that probability as a fraction. In the numerator, we want the number of ways that we could successfully get the event that we're looking for. So in the numerator of this fraction, we can list in general the number of events. In our example, the number of ways that we can get a heads on the flip of a coin is just one. Coin only has two sides and there's only one head. So in this part of the fraction, we would put a 1. In the denominator, we want to list or enumerate the total number of possibilities or possible outcomes. Total number of outcomes that are possible taking this action. In this case, the flipping of a coin only has 2 possible outcomes. So in the denominator, we put a 2. Back to answering our question, with this notation, we could say, using a P, what is the probability of getting the event heads on the action or the experiment of flipping a coin? That's going to be equal to this fraction. The number of events that would result in heads, there's only one side that could come up to be a head, so the number is 1. The total number of possible outcomes, well, we can get a heads or a tails. There are only 2 possible outcomes. So the probability of flipping a heads is 1 out of 2. This, of course, is equivalent to 50%. Let's ask another probability question. What is the probability of rolling greater than 4 on a common die? A common die is a 6-sided die. So with our notation, we could ask the question this way. What is the probability P of getting greater than 4 when we roll a common 6-sided die? That's going to be equal to a fraction. In the numerator, we think of the number of possible ways we can get this event greater than 4. And on a die, if we roll a 5 or a 6, then there are 2 possible ways of getting greater than a 4. So we put the number of possible events that satisfy that condition. In the denominator, we have the total number of outcomes. When we roll a die, there are a total of 6 ways that we can get an outcome, and that total is put in the denominator. The probability of rolling greater than 4 is 2 out of 6, or 2/6. We could reduce this to 1/3. We could convert it to a percent, but we would force to express it as a decimal that doesn't end, 33.3 repeating percent. Let's keep it as a fraction. We're going to ask one more probability question. What is the probability of drawing a jack from a deck of cards? In probability notation, we could be asking P, the probability of drawing a jack. J for short. Now, a deck of cards, a standard deck of cards, there are many games, and probability and familiarity with a deck of cards is something that can be useful and fun in life. So I'm going to take a moment to include in our notes what is in a standard deck of cards. There are 52 cards total in a standard deck. Now, that would not include jokers, so this is a standard deck of cards without jokers. In a standard deck, there are 4 what we call suits. Those are the spades, hearts, diamonds, and clubs. And I've attempted to draw what they would look like as symbols on the cards. Those are our suits. And in each suit, there are 13 ranks. Ace, king, queen, jack, and the numbers 10 through 2. And I've written them in here in a typical descending order, where ace is usually high, and 10s are higher rank, and the 2 is the lowest rank. That makes 13 cards, 13 ranks in 4 suits for a total of 52 cards. 26 of those cards are red. Any card that is a diamond or a heart is a red card. And 26 of the cards are black. Half of the deck is red and half of the deck is black. Those cards that are spades are black, and clubs. There are many ways that we could ask probability with a standard deck of cards. This one here, the probability of drawing a jack, is considering how many jacks there are in the deck. This probability is going to be equal to, in the numerator, a fraction, in the numerator, the number of events that satisfy that looking for a jack. The probability of the outcome will be a jack. There are 4 jacks in a standard deck of cards. There is 1 for each suit. Jack of spades, jack of hearts, jack of diamonds, and jack of clubs, for a total of 4 possible ways to get a jack. In the bottom of this fraction, we need the total number of outcomes. If we draw a single card out of a standard deck, there are 52 cards. So there are 52 ways to draw a single card. The probability of drawing a jack is 4 out of 52. We could reduce that fraction to 1/13. Again, we could convert it to a percentage, but that percentage would be a decimal that would keep on going. So the exact probability is 1 out of 13.